Hello everyone, this is going to be a short little lesson today on graphing cubics. This is section 5.1. So watch this video and then there's going to be my HRW homework that has problems from this section as well as graphing polynomials from today's class. All right, before we get into that, let's take a look at some parent functions that we've done previously. Y equals x, this is just going to be a line, a 45-degree line to the origin. Y equals x squared, this is a parabola that looks like this and then mirrors on the other side. Today we're going to be looking at y equals x to the third, and it's going to be kind of a curve like this, but instead of like a parabola and going up on the other side, it's going to curve back down like that. And then y equals x to the fourth, this is kind of like a fat parabola like this. All right, so y equals x to the third, this is my parent function. This is kind of like what that basic normal function looks like, and then we're going to transform it all over the place. So on this, if you ever don't know how to graph something, you can always make a t-table where we have x and then we have f of x, which is x to the third. So whatever we plug in for x, we're going to cube it and we get our f of x value. So we can pick anything for x. And that's the other thing, because we can pick anything for x, my domain is going to be all real numbers. Okay, I can put in -2, -1, 0, 1, 2. All right, now, whatever I put in for x, I'm going to cube it, right? -2 cubed, which is just really -2 times -2 times -2. So 2 times 2 is 8, but we have 3 negatives, so this answer is going to end up as -8. So this is really down here. There's my point. All right, -1 cubed. -1 times -1 times -1 is just -1. 0 cubed is 0, so it's going to go right through the origin. 1 cubed is 1, and 2 cubed is 8. So this graph on the right-hand arm looks kind of like a parabola, except growing a little faster, because now we're cubing it instead of squaring it. Now here's the thing. Instead of like the blue line here, like a parabola, y equals x squared going up on the left, now when we plug in values for x, we can get negative y values. So that arm is going to actually go back down here instead of curving up. So there's my parent graph. Couple things. This is an odd function. Okay. End behavior as oops. So as x approaches -infinity, so as we go to the left, f of x approaches -infinity. And then as x approaches positive infinity, so as this graph goes to the right, our f of x value is going to approach positive infinity. Or more importantly, just know that this arm is going up on the right and down on the left, because that's going to help us with the polynomials as well. All right, symmetric, this is symmetric about the origin. Symmetric about the origin, which means is if you kind of turn this 180 degrees, you would have, there's 90 degrees, and if we turn it 90 more degrees, they're symmetric about the origin, okay? Or basically every point that you put, like 2, 8, if we do -2, -8, that's also a point. If we just make both of those points negative, it shows some symmetry about the origin. Just remember that this graph is symmetric about the origin, the parent function here. All right, domain is all real numbers because I can plug in any x value. Range is all real numbers because any y value can come out. And also this graph goes down and up forever. So all real numbers for both of these. Okay, keep this in mind here as we look at these next couple graphs. The important thing is from that kind of inflection point there, we're going over 1 up 1, over 2 up 8, and then same thing on the other side but negative. So back 1, down 1, and then back 2, down 8. Those points are going to help with our stretches and compressions. All right, parent function, we've done this before. A, h, and k values, they still mean the same thing. A, if a is greater than 1, we have a stretch, vertical stretch. A less than 1, we have a vertical compression. And if we have a negative A value, this is going to reflect over the x-axis. So think up on the left, down on the right. My H value is left and right, but backwards, and then my K value is up and down. All right, let's see what these look like when we apply them. Okay, here's a function. This is a cubic because x is being cubed. Describe the transformations compared to the parent graph and graph the function. So describing the transformations, this x minus 5 is 5 right. And then this minus 2 is down 2. So those are my only two transformations. So that normal vertex that's at 0, 0 is being moved 5 right and down 2. And now we just have our normal shaped graph. There's no stretch or compression or reflection. So over 1, up 1, back 1, down 1, and then somehow get an 8 in there. All right, so 2, 8, and then back to down 8. These grow really fast, so they kind of go off of our page pretty frequently. So that 0.11 is really important. Okay, there's my cubic. All right, next one, let's describe these transformations. X plus 1 is left 1 unit, up 2 units, and then this value of 3 is a vertical stretch by a factor of 3. So first thing we're going to do is plot that turning point. Left 1, up 2. So right there, that's where it's going to turn. Now, instead of being 1, 1, it's now being stretched by 3 times. So take a look at this Desmos real quick to kind of see what that looks like. Okay, here's our normal parent function that goes through 1, 1. As I slide that A value to 2, you can see now it's going through the green dot. So as we go over 1 unit, now instead of going up 1, it's going up 2. And as I put in an A value of 3, now instead of going over 1, up 1, now it's going over 1, up 3 units, okay? So that vertical stretch is being stretched 3 units. So for each 1 unit you go now, you're going up 3 times as far. All right, let's see what that looks like on our graph. So vertical stretch by a factor of 3. So instead of going over 1, up 1, I'm now going over 1, up 3 times as far. So there's my new point. And then same thing on the other side, we're going to mirror that. Okay, now this looks linear, right? When we just deal with these points, don't draw a line, okay? We need to make sure that we throw a curve in here. So I come down really steep, and as I reach that middle point, you could see that I could either go up or back down, but I'm going to make it flat here and then go back down. Okay, make sure you get a little bit of a bend in the middle there, okay? All right. Next one here, I have x minus 3, so this is going to be right 3 units. I have minus 1 at the end, so this is down 1 unit. Now I have 2 things going on with my A value. First of all is 2, this is going to be a vertical stretch. And then I also have a negative sign, so this is going to reflect over the x-axis. All right, so instead of having a guy that looks like this, that's doing one arm up on the right, down on the left, it's actually going to flip and be the opposite and go up on the left, down on the right. All right, let's see what this looks like here. We're going right 3 units, down 1 unit. So from here, I need to do 2 things. I need to first do my vertical stretch. So over 1, up 2. And now you can throw in the reflection, or you can graph it first and throw in the reflection later. But basically, this is my graph here. The only thing is I need to make it kind of do the opposite and go up on the left. So I'm going to reflect each of these points kind of around this line here. Okay, so this point that's over 1, up 2 is now going to be over 1, down 2. And this point that's back 1, down 2 is going to be back 1, up 2. Okay, so you can kind of do it all in one fell swoop. You can also do it separate like this, but the pink graph is the one that has my vertical stretch and my reflection in there. Domain and range again, all real numbers for these cubics. Let's take a look at one more. All right, we have a couple things here. We have right 1 unit, down 1 unit, and then this 1/2, because it's less than 1, it's growing half as fast, is going to be a vertical compression, okay? Picture pushing down on the top and the bottom. So we're going to move that turning point, right 1, down 1. Now, if you can imagine, instead of going my normal growth, when I go over 1, up 1, now I'm only going over or up half as far. It's only growing half as big. So using these 2 points now, in the pink, I'm going to go over 1 and just half as much. And then down, back 1 and down half as much as before. Okay. Now we can also use those points that we know from that turning point, 1, 1, 2, 8, right? We're multiplying this by half, or just growing half as big. So we can also go over 2, up 4 as well. So from that middle point, we can go over 2 units, 1, 2, 3, 4, up 4, and then back to 1, 2, 3, 4, down 4. All right, so there's my pink points. Now I have kind of just a fatter, more compressed cubic. Draw through those points. That's the fun part of all of this, making a nice, pretty graph. There we go. Oh, and there it goes. Come back. All right, there we go. So you can see a little bit fatter. Each of those points are compressed, and they're half as tall as they would be if we didn't have that value of 1/2. All right, good job. Go ahead and try some